Yeah, hello everybody, and welcome to our talk, Test Like a Robot, Monitoring Like a Bavarian. First of all, thanks for having us. It's a pleasure to represent our company and show what we have implemented over the last few years. Today, my colleague Sachmann and I, Sebastian Böhm, will show you the beginning of our journey with Robotmk and Checkmk, followed by some main reasons for choosing these tools. We would also like to talk about our goals and the workflow, how it looks like. This summarized our synthetic monitoring, which ensures the service availability at ITM, the IT service provider for the City of Munich. We are both working as DevOps engineer, maybe a little more op than dev. I have been part of the monitoring team since 2016. In 2020, Maxi joined us and completed our team. Since then, we're both working together and started to establish Checkmk as our infrastructure monitoring platform in 2022. For understanding, speaking about our infrastructure monitoring, we mean the monitoring of ITM. Checkmk is not our baby, but it feels like it is. So, let's have a quick look for some data and facts of ITM.
As already mentioned, ITM is the IT service provider for the City of Munich, but it also belongs to the city administration itself. We and our about 1,000 colleagues operate about 1,000 applications on more than 6,000 virtual servers. This includes even applications developed in-house. The Checkmk environment we implemented to monitor our infrastructure consists out of 8 sites. There we monitor about 4,000 hosts with more than 200,000 services. And we also migrated 28 test cases of synthetic monitoring from our old monitoring tool to Robotmk and Robotmk. With this Checkmk environment in mind, let's have a look at our journey to and with Checkmk and Robotmk. At the end of 2021, the maintainer of our old synthetic monitoring informed us that the development would be discontinued and that the tool will be made open source. However, there was no community for this tool, and Basti and I didn't have the resources or know how to maintain it ourselves. We were looking for alternatives. At this point, as often, Basti visited the yearly OSMC, the Open Monitoring Conference in Nuremberg, where Simon, of course, presented his plugin Robotmk for Checkmk. Also at this time, we weren't quite satisfied with our current infrastructure monitoring. We were therefore looking for a new solution, or at least an alternative. Because of that and the inspiration from Simon's talk at the OSMC, we decided to do a proof of concept with Checkmk and Robotmk. Therefore, we started in 2022 with the proof of concept, testing both tools together and evaluate a potential replacement of both tools or old synthetic tools. The POC showed us that a migration would be time-consuming for us and would need some adjustment. But in the long term, a move to Checkmk would make sense for us. Also, on the other hand, Robotmk already showed itself to be well integrated into Checkmk and as a good alternative to our current synthetic monitoring. Therefore, we started the migration in 2023 of the infrastructure and the synthetic monitoring. After more than a year of migration time, we were finally able to provide Checkmk as our new infrastructure monitoring platform to our colleagues, using Robotmk already as a plugin. And this already sums up our journey with or to Checkmk and Robotmk, but we want also to give you a quick insights to the reasons behind our decision. At first, for us really important, Robotmk relies on the Robot framework, an open source test and process automation framework with a large and supportive community. After our last experience, this gave us more trust in the use of such a tool. Due to the foundation, the background of Robot Framework and the great community, there are already some well-developed libraries for most of the common use cases. For example, the browser and crypto library, which we use in most of our test cases. Also, the human-friendly or readable syntax of the check scripts makes it easy for beginners to understand already existing test suites and test cases, but also to develop new on their own, speaking from our experience. And of course, as a last point, the integration into a well-functioning monitoring tool like Checkmk. Only therefore, the migration was considered by us. Speaking of Checkmk, let's also have a quick look at the reasons for Checkmk itself. At ITM, we rely on infrastructure using cloud platforms, container environments, as well as virtual machines and appliances. We were therefore looking for a monitoring tool which could support all of these. Also, we were looking for a tool which would keep up with new technologies and standards. A great example for that is the upcoming support for OpenTelemetry in Checkmk. Another point, not all of our colleagues are command line ninjas and feel comfortable managing a bigger monitoring environment on a CLI. They are therefore quite happy about the setup menu in the Checkmk UI. This makes it easy for them to support Basti and me in our day-to-day operation, using the search and clone function in the setup menu to implement new custom checks for our colleagues. Furthermore, as a public sector organization, we try to follow the principle public money, public code wherever possible. We are therefore quite pleased that Checkmk is at least built on an open source core, even though we are passionate and satisfied users of the Enterprise Edition. All these reasons together, with the variety of the built-in plugins and the extensibility and customization that Checkmk offers, convinced us to make the move at the end, and it's a decision we do not regret today and would do again. And as last, a little bonus. Martin already mentioned it. As the city administration of Munich, or the City of Munich, we happily rely on a solution or a software solution from a Munich-based company. So now you know how we ended up using Checkmk and Robotmk. Now let's have a look how we use synthetic monitoring at ITM.
Okay, so we have two main objectives for the synthetic monitoring. The first is the actual main reason we need a monthly report for the availability of our services. Secondly, we need an end-to-end monitoring tool that alerts us within minutes as soon as an application is no longer available or no longer behaves as expected. The combination of Robotmk and Robot Framework helps us to continuously monitor the application performance. The gradual recording of runtimes in Checkmk allows proactive action to be taken long before users complain. We are currently focusing on web tests, but we also plan to extend the end-to-end monitoring tool for the desktop testing, for example, our Citrix farm applications. Now, let's take a look at some of our applications that we monitor with Robotmk. First, the website of the Abfallwirtschaftsbetrieb, which is the largest public waste disposal company in Germany. It is one of the most frequently visited websites we operate. We all know Germany is known for its waste separation system. Therefore, this website provides information about garbage collection, disposal, and recycling in Munich. That includes one of the main features that you can see behind us, the collection calendar, where citizens can check when the next waste disposal takes place. Another example is the Kita Finder. The Kita Finder is an application for parents who are looking for a childcare place. For those responsible, this means that they have the opportunity to process the incoming requests. We monitor this website all year round, and it becomes especially important if the new childcare places are available. This is usually in 2 specific dates in the year. And at last, an application that many people may know, for example, if they order a new passport or a driver license in Munich, it's called a Terminvereinbarung. The application consists of 3 main components: the appointment booking, the management platform for the employees, and the visitor displays in the citizens' offices. Especially the visitor monitors and the appointment booking are extremely important because it's the direct interface for the citizens. If these components do not work, we quickly have dissatisfied citizens and critical media reports. So we have now seen a few examples of applications that we monitor. Now let's take a look at our second purpose, the availability report. To ensure the availability monitoring, we run the test case every 5 minutes, 24/7. These results are reduced to the time periods of the service level agreement and evaluated monthly in a Checkmk report, where we use the opportunity to highlight the lower availabilities. The report will also be made available to our performance managers They will check the availability and address the possible lower scores. Now, you know how we use the synthetic monitoring at ITDM. We also want to show you how we work with Robotmk and Robot Framework on a daily basis and manage to provide the monitoring and the reporting.
Our daily work with synthetic monitoring can be divided into 4 stages, maybe 5 if we include our little quality assurance phase at the end of the workflow. We start with the local development of new test cases or the improvement of existing test cases, followed by pipelines in the dev and master branch of our GitLab repositories, and as a last step, of course, the configuration of the Robotmk agent rule. First, we will have a closer look into the local development. Here we use the Visual Studio Code with the Robot Code plugin for more IDE support. There, test cases can be developed step by step using the debug mode and console of Visual Studio Code. Also an essential part at this point are the developer tools of our chosen browser. There we try to find the best matching selector for our next action. This enables us to build test cases keyword by keyword. When developing new test cases, we try to address all components of an application at least once per test suite. In most cases, this simply means the application server and the database server. But this could also mean a dedicated search engine, an editor, or for example, a PDF generator. To cover those components, we build test cases consisting out of 4 or more steps, which are represented by user keywords developed by us. Firstly, we will simply open or visit the website we want to monitor, and as a second step, if needed, we will log into the website or the application. If that's happened, there's the main part of the test case. We simply try to execute a typical search in this application and ensure that the result we got is that what we expected. And as a last step, we of course try to log out from the application. There could be some components of an application that only need a quick visit or at least need to be opened and checked that a specific element is shown. The visitor displays is shown by Basti, and some of our map-based services are a good example for that. When we finish the step-by-step development of test cases, we do a final run on our local environment to check if everything works together as expected. If that's the case, a first commit to our pipeline or to our Git repository can be made to the dev branch of this repository. This commit, of course, will trigger our first pipeline. The started pipeline job will trigger an Ansible playbook. With this playbook, we automated 3 main steps of our pipeline. Firstly, the dev branch of the current repository will be cloned to our Robotmk test node. And secondly, the test suite in this repository will be executed using Robot Framework on the test node. And as the last step of the playbook, the returning output files will be uploaded to an S3 storage. After the playbook run was completed, the output files will be downloaded back in the pipeline and analyzed. By that, we can set the state of the pipeline and include these output files as artifacts to the pipeline job. With those results, it's possible for us to evaluate if the new commit to the dev branch is suitable for the master branch or the production. And if that's the case, a merge request can be made to the master branch, which, of course, will trigger another pipeline. And you guessed it right, the pipeline also will trigger an Ansible playbook. But this time, this playbook only has one task. It simply clones our repository to all of our productive Robotmk hosts. This means that all of our test suites we develop are available on all of these hosts. By that, we completely shifted the decision on which suite is executed on which of our hosts to the configuration of the agent rule. For us, this means it's not necessary for us to connect to any of our test nodes to update the test suites or implement changes, or to change anything on the configuration of the execution. The update of the test suites or changes are simply automatically pushed by the GitLab pipeline, and the management of the execution is completely covered by the agent rule, which we, as a last step, will cover now. In the configuration of the agent rule, we will try to find a mixture of parallel and sequential execution using the available features of the groups and plans. By that, we want to ensure to use the resources of our hosts as efficient as possible. but always making sure that the test suites are executed smooth and reliable. By that, we are having our 5-minute execution interval in mind. Also, as some of you might know, since Checkmk 2.3, Robotmk uses RCC to create the Python environments needed to execute the test suites. For this purpose, we also created a central environment configuration, of course, in a GitLab repository. This includes the conda YAML file, where the versions of Python, Robot Framework, libraries, and other dependencies can be defined. With that, we made the lifecycle for us very easy. We can simply edit the conda YAML file with new versions and push it to all of our test nodes, and the new environment configuration can be used by the Checkmk agent and Robotmk. And as our last step, in addition to the already mentioned groups and plans, we assign an explicit host to this agent rule. By that, we decide which subset of our suites will be executed on which of our hosts. And with that, we already covered our workflow. Of course, a little bit of agent bakery is already needed, but that's it. But we explained the flow or the workflow quite straightforward without any issues. Therefore, Basti now wants to show you some of the problems we encounter by developing new test cases and operate the synthetic monitoring, and of course, at least want to try to show you some solutions for these problems.
Okay, so now Maxi has given you a deeper insight into our designed workflow. I would like to inform you about our daily issues and the solutions we suggest for them. The first point that many of you may know, regardless of infrastructure or synthetic monitoring, no downtimes are set for maintenance. They could be forgotten or even simply ignored, but in our setup, no downtime means slower measured availability, even if it's a plain maintenance. There is no real solution to this problem apart than automation. We just try to keep reminding people of the need and purpose of downtimes. Also, the UI for setting downtimes has already been optimized in Checkmk 2.3. We even give the people documentation in the hand and to make the sense of the downtimes even clearer. Some of you may be familiar with the problem of monitoring and testing applications that not are designed for this purpose. In this case, we're referring to applications which do not provide any unique attributes. To find suitable selectors, there are some add-ons in common browsers, but these often do not provide stable or readable selectors. In the end, you just have to be creative and combine the tools provided by XPath, CSS, or locators of used libraries. However, we do have 3 hints for you. First, don't use wildcards or filters in common elements such as diffs that causes performance losses. Be more specific by using attributes and text. Second, try to find the suitable selectors where it is clear which element is being addressed. And the third one, if you use images, please note 2 things. The first thing, the display in your developed environment maybe differ from that of the real Robotmk host where the checks are running. Use screenshot keywords if necessary to see how the application really appears. And furthermore, if your images should be significant and as small as possible. This also ensures better performance and prevents alerts for small deviations. And last, always expect the unexpected. In addition, there are always some test cases that fails for unknown reason in a few runs, but usually they work. Good luck convincing developers and operators that something is off here. For this purpose, we use the mentioned fifth phase of our workflow, the quality assurance. In this phase, we already let the test suites run in its defined interval, but without notifications and without an availability report. During this time, we check whether the test suite behaves as expected or if there are any edge cases that we can overlook during the development. Yeah, there are certainly other issues that we can point out here. Debugging such issues often leads us to every IT person's favorite answer, hey, it works on my machine. So with this in mind, have fun with Robotmk and Robot Framework and happy monitoring.